All right, give it a shot, please, for real. Okay, let me give you the definition. Okay, you're going to do it via the limit definition, which we haven't done in a minute. But remember, f prime of x equals LIM, h approach 0, f of x plus h minus f of x over h. Remember, technically, there used to be an x plus h and a minus x, but then they like canceled each other out to just give you the h. So let's see what we remember. Okay, and leave yourself like a little bit of space here. Okay, so the first thing I'm going to do is find my f of x, which is right here. Okay, so f of x equals 3x squared minus 8x plus 13. Then what happens when I turn my f of x into an f of x plus h? Do you remember? You just let the plus h sneak in where the x's are. So my f of x plus h would be 3x plus h squared minus 8x plus h plus 13. Okay, so here's what I want you to do. Expand this out. You're going to do the squaring first, then times by 3, times the minus 8 in, and then plug it into your limit. And remember, a bunch of crap should cross out. Do you remember this or no? Are you going to be able to do Monday morning too early? Okay, fine. So x plus h times x plus h again. We can do it together. It's okay. All right, so x times x is x squared. Now, I'm going to times them all by 3 as I go so that I don't have to do it in 2 steps. So x times x is x squared, and then I'm going to times it by 3. Okay, next term would be x times h, which is xh, but then it'd be h times x, which is another xh. How many do I have? 2, and then I'm going to times by 3. So how many am I going to have? 6 xh's. Okay, because I'd have this xh from the outside 2, this xh from the inside 2. That's 2 total. Times by the 3 on the outside gives me 6. Okay, then h times h. Times it by 3. Okay, now we're going to times our minus 8 in. 8 times x is an 8x. 8 times h is an 8h plus 13. And then remember, I'm going to do the little boxes thing. This is going to replace this. And then this is going to replace this. Okay, so go ahead and do that step. So purple box is going in purple box. Green box is going in green box. Okay, I'm going to have to make mine ugly, but sadly. Okay, now one thing I do want to point out is that technically, remember, it's purple minus green. So what's going to happen with this minus if I'm minusing this whole green box? We need to distribute the negative. So my negative will be on the 3. What will it be on the 8 if it was already a minus 8? Now it'll be a plus. And then my minus on the 13 will go to a minus 13. Okay? You hate this? Okay, so let me one more time. We're minusing the green box, yeah? But the green box has 3 things in it, so we have to make sure to minus each one. So I minus on the 3x squared. I minus on a negative 8, turns it to a plus. And then I'd also minus on the 13, which makes it a subtraction. Okay, then we're looking for stuff to cross out. Remember, if it doesn't have an h and you didn't mess up, it should cross out. So I have a 3x squared and a what? Negative 3x squared. I have an 8x and a negative 8x. I have a 13 and a negative 13. So then the only things that are going to stay are my 6xh, my 3h squared, and my minus 8h. Okay? Now, quick question, why is it significant that everybody on top has an h? Because now I can do what with it? Take it out, GCF. Okay, so we're going to GCF the h out to the front. And then remember, the goal of that is to cancel the h on bottom. So my h on top, I'm pulling it out, is going to be a 6x plus a 3h minus 8. And then remember, the reason we did that is to cancel that h on the bottom, so now it's gone. Okay, then from there, what's my goal? What is h approaching? What number? 0. So that's going to zero out my 3, because 3 times 0, that would be gone. So remember, you only plug it into the h's that survive. So the h in front and the h on bottom, those are gone. So my final answer is 6x minus 8. Okay? And remember, this equation is the derivative, which will tell me the exact slope at any x value that I want. Do you remember? Okay, now do it via the shortcut. So remember, we saved ourselves just a little bit of space, just so you don't forget how to do it.
But why do we have to know?
Just because I made you do it for fun. Okay, so this is the slope formula for any x value. Okay, that is the slope formula for any x value that you want. But then remember, after we did these notes and we painfully went through every step, we learned the power rule. Okay, so let's take a look at our equation, the little space that we saved. Okay, how do I do the power rule? 2 times 3 is 6. My x squared goes down to a regular x. My 8x is to the 1. What's 1 times negative 8? And then x drops to the 0. What happens to the constant? Wow, look, the same answer. Wow. Okay, good little warm up. Turn the page.
Over there.
Wasn't that a fun little walk down memory lane? Is that too dark? Too dark? This way? All right. All right, turn the page, turn the page. All right, let's refocus. So every time that you do the derivative rule, I want you to remember what you're skipping. Okay, the ancient nerds spent so long figuring this out so that you never have to do it again, except I might make you. Okay, so what we're going to cover today is differentiability. Okay, that's what our notes are actually on. You have to know how to take the derivative via power rule by the end of the day today, no exceptions. Okay, otherwise the next 2 days are going to be really bad. So today's your day to kind of get it together because differentiability involves taking derivatives. So right here at the top, a function is differentiable if the derivative exists for every x value on the domain. So there are two ways that your derivative cannot exist. The first one is that if you can't draw a tangent line, you can't have a derivative. Because remember, what is a derivative? The slope of a tangent line. So let's put right here. Need to draw tangent line and calculate the slope. Okay, so differentiable means that I have to be able to draw a tangent line and calculate its slope. Okay, and there are four ways that that could not be possible. Okay, the first one is, what if you have a break in the graph? So do we have a jump discontinuity here? Okay, at 4. So I want you to tell me, how could I draw a tangent line that's going to lay right next to both of these pieces if they're not connected? Okay, so the first graphical indicator would be any discontinuity is automatically not differentiable. Okay, because if the graph is disconnected, I can't draw a tangent line that's going to connect pieces that aren't even in the same spot. So item number 1 is any disconnect in the graph, that's a no. Okay, step number 2 is a cusp or a corner. And the reason that you cannot be differentiable at a cusp or a corner is because there's no way to lay the line perfectly along the graph where it lines up with the slope. So let me show you what I mean. Do we see a cusp or like a kind of pointy point? Okay, at 8. So think about at 8, how could you draw a graph to perfectly like match if it's a corner like that? So here and here, okay, those are cusps or corners where it's not possible to draw a tangent line at that spot. So not possible to be tangent. Because even if you can kind of line up to match this side, so like imagine I'm trying to do it on this way, it'd be a downhill line. But then if I want to be tangent on the other side, it's an uphill line, and they don't, like, I can't like teeter on that perfectly. Okay, so cusps and corners are no. Okay, the third option is any kind of vertical tangent. Okay, and here's the problem with a vertical tangent. You can draw the tangent line, but then what's the slope of a vertical line? Starts with a U. Undefined. So remember, I have to draw the tangent, which I can do, but then when I go to calculate its slope, if it's perfectly up and down, I can't calculate that. Okay, so that happens at 11. Okay, if you want to draw it in at 11, my graph goes perfectly up and down. I can draw the tangent line, which actually somehow I totally missed the graph, but it's fine. Okay, but the slope is perfectly up and down. I can't calculate it. Okay, so I'll put here, can draw a tangent, but because vertical, slope is undefined. Okay. And then actually, let me differentiate between a cusp and a corner. Okay, a cusp is when either side is bent. A corner is like an absolute value. Okay, so if both sides are linear, typically you would call it a corner. Okay, and then if either side is bent, you would call it a cusp. Okay, so these are technically both cusps. Okay, all right, so go down to the next graph. Okay, it says find where the instantaneous rate of change is horizontal. Okay, horizontal would be what slope? 0 slope, which means it should look perfectly flat. Okay, so let's find that on the first graph here. How many flat spots do you see?
3.
There are 3. One of them's here at -6. One of them's here at 0. And then there's one more flat over here at 6. So I'm going to write HT for horizontal tangent happens at -6, 0, and 6. Okay, but remember, horizontal tangents, you can draw the tangent line and its slope is perfectly flat. Okay? Next, we're looking for vertical tangents. I should be able to draw the tangent line and it should be perfectly vertical. Where does that happen on the first graph? 3 is correct. Okay, so my vertical tangent is at x equals 3. Okay, now let's talk about where my graph is not differentiable. That means I cannot draw a tangent line and also calculate its slope. So there are 4 things we're looking for: disconnects, cusps, corners, or vertical tangents. So where do I have a cusp or a corner? Okay, not differentiable because it's a cusp. Okay? And then where is one other spot? Okay, 3, not differentiable. Why? Because it's a vertical tangent. Now, for horizontal tangents, are those differentiable? Yes, because a horizontal line has a 0 slope. Okay, that counts as a slope that I could figure out. Okay, go ahead and do the next one. Find your horizontals first. There should be a total of 3. So you should have one at -6 again, one at -4, and then one at 2. Remember that horizontal tangents do count as differentiable, but vertical tangents do not. Where is my vertical? At where? -1, correct. Okay. Then remember, any vertical tangent is automatically not differentiable. Where else is my other not differentiable spot? 5, which is a cusp. Okay, so we'll just circle those 2 and put not diff. Okay? All right, go ahead and turn the page. So the first part of today's assignment is you're just looking at graphs and you're going to say where they're not differentiable. That part should be pretty easy. It's going to be just like that. Okay, turn the page. Okay, on the next page, you're going to have to use the formal definition of differentiability. And on y'all's test, I don't know, you have to follow the format for the formal definitions. So I think some people are just writing like, there's a jump and answering it. You can't do that for the AP test. So when we go through these definitions, okay, you want to make sure that you're explicitly following them for the notes because you get to use your notes on quizzes. Okay, I don't expect you to have it memorized, but if you have a cheat sheet, I expect you to be able to follow those steps. Okay, so a function is differentiable if, number 1, f has to be continuous. Okay, so f is continuous at A. Okay, if it's not continuous, then you automatically know it's not differentiable because you can't draw a tangent line if there's a break in the graph. So we're going to outline the steps for that, but you already know these, or you should. Okay, step number 1 is that the limit from the left is equal to the limit from the right. Okay, and this is old stuff that we already covered. So the first step to be continuous is your left and right limits have to match. Okay, the second condition that you would check is that you have to have a defined y value. So I'm going to put f of A equals defined y value. Okay, and then the third step is hopefully you remember these two have to equal the same number. So for your step number 3, your y value and your limit have to equal each other. Okay? So if your graph is not continuous, meaning all three of these steps are not true, okay, then you don't even go on to the second part. So it has to be continuous and it has to be differentiable. F is differentiable if the limit x approach a from the left on f prime of x is equal to the limit as x approaches a from the right. So obviously the first part of this is old news. Okay, this is the new part. So notice now it's still a limit from the left and the right, but instead of checking regular f, we're checking f prime, which is a what? Starts with a D, derivative. Very good. And derivatives tell you the slope on either side, that they have to have the same slope. Okay? All right, so let's do number one. Okay, we're only going to do a couple of these formally, because obviously your hand's going to want to fall off if we do them all that way. So first thing we're checking is continuity. Okay, I have to check the limit from the left and the right. They have to come out the same. What is my breakpoint? So I would do LIM, 3 from the left, and then LIM, 3 from the right. Okay, remember that for a left side limit, what do I want for x's? To be greater than 3 or less than 3 for a left side? Less than, so I'm plugging into the top. 2 times 3 squared minus 4 times 3 plus 8. Okay, remember, follow PEMDAS. 3 squared is 9. 9 times 2 is 18. So we have 18 minus 12 plus 8. 18 minus 12 is 6. 6 plus 8 is 14. Okay, that's my left side limit. Okay, let's do the right side. We want x is greater than 3. That'd be 6 times 3 minus 4. That's 18 minus 4, which is also 14. So left and rights both came out to 14, which is great. Condition 1, we're good to go. Condition 2 is I have to have a defined y value, which could be built into one of the things you just did, or it could be its own piece. Now, in this case, my equal to is already built into the bottom. And what did that answer come out to be? 14. So I'm not going to rewrite all of that. I'm just going to put that I know that my f of 3 is 14. Because my y value is included in the equal to that was already in the bottom piece. Okay, step number 3 is that those had to match, do they?
Yes.
Yes. So step number 3 is that I would state that f of 3 and the limit as x approaches 3 do match. So my graph is continuous. Okay, after we check that it's continuous and verify that, we're going to check if it's differentiable. That's going to require you to take the derivative of the piecewise. You're just going to take the derivative of the pieces. So up here at the top, put f prime of x equals. And then take the derivative of both pieces. So the top is a 2x squared minus 4x plus 8. What's the derivative of that? 4x minus 4, perfect. And I'm going to use that derivative everywhere that x is less than 3. Okay, on the bottom, what's the derivative of 6x to the 1 minus 4? 6, great. I'm going to use that for everywhere x is greater than or equal to 3. And then I'm just going to check that those pieces match. So let's do it. This is for differentiability. Bill and T. Okay, LIM. X approach 3 from the left of F prime, and LIM, X approach 3 from the right of F prime. Okay, my right side is easy because it just came out to a number. The answer was 6. So I'm just going to copy that because I don't have anywhere to plug the 3 in. Okay, but then for the left side, 4 times 6 is 24 minus 4 is 20. Oh, crap, you're right. It was a 3. Okay, then 4 times 3 is 12, and 12 minus 4 is 8. So my left side slope is 8. My right side slope is 6. Do they match? Then it's not differentiable. It is continuous, but it's not differentiable. So let's put CONT, but not DIFF. Okay, that would be your conclusion. It is continuous because the first 3 conditions were met, but it is not differentiable because my slopes didn't match. Okay? Try the next one, but maybe let's be a little bit lazy. So I'm going to put lazy, do not copy. Okay, what I mean by that is if it's a quiz, don't follow this format. Okay, so first thing I'm going to check is if it's continuous. Do the left and right sides plugging in 0. So let's do left first, right second. So 0 minus 0 plus 5 is 5. 0 minus 0 plus 5 is 5. Okay, so left and rights came out the same. Okay, because 0 is such an easy number to plug in. Now, does one of them include the equal to? Yes. Which one, top or bottom? Bottom. So for my y value, it's also 5. So I'm going to put check for CONT, continuous. All right, let's go on to the derivative side. Take the derivative of f using your power rule. Okay, thanking the ancient nerds that they figured it out so we don't have to do it the long way every time. Thank you, ancient nerds. Okay, 6x squared, what's the derivative? 12x minus 2. Remember, the plus 5 is going to cross out because it was a constant. Okay, I'll use that for x is less than 0. For the bottom, it's a 4x3. What's the derivative? 12x squared minus 2. That's for x's that are greater than or equal to 0. And then I check the limit for the derivative from both sides just to make sure that they match. So LIM, x approach 0 from the left of f prime, and then LIM, x approach 0 from the right for f prime. Okay, we're plugging into both of those. Are they going to come out the same? 12 times 0 minus 2 is -2. 12 times 0 squared minus 2 is also -2. Then automatically we know that it is differentiable. Okay? So we'll put therefore CONT and DIFF. Okay? And this is primarily what you'll be doing for your homework. I don't think you need to write it out for every example on your homework. You should just know for quizzes and tests you'll have to. Okay, turn the page. Okay, we're only going to do one more of this type. Will you go to number 4? Okay, we'll skip 3 and go to 4. Okay, for number 4, can you check if it's differentiable? Or sorry, if it's continuous? Shall we be lazy?
Yes.
Okay.
What does that mean?
It just means we're not writing like LIM, F of this. We're just doing left, right, Y value. On quizzes and tests, if it's free response, yes. Okay, so remember, we're being lazy, do not copy. Okay, I'll put do not copy format. All right, so we're plugging into 9. 9 squared minus 5 times 9 minus 10. That'd be 81 minus 45 minus 10. What is that going to come out to be? So we're basically taking away 55. What'll it be? Do it. Fine, use calculus. Thank you. Wait, it can't be 46. 36? 26, yeah. Can't be 46. Okay, great. Now do the right side. So 6 times root 9 plus 8. Root 9 is 3. 6 times 3 is 18. 18 plus 8 is 26. Okay, my y value could be its own piece, or it could be built into one of those with an equal to. Built into top or bottom? Bottom, which is great. That means the answer is 26 again. CONT, we're good to go with continuous. Okay, take the derivative. Okay, derivative of the top should be pretty simple. What is it? 2x minus 5, and I'm going to use that for any x less than 9. Now let's talk about the bottom. We have a square root. Okay, we're going to get into harder derivatives next class. We're just kind of setting the tone for next class. Okay, you can do it. You're fine. A square root is the same as what numerical power? 1/2. Very good. So let's write up here. Okay, that a square root is the same as a 1/2 power. So if I want to take the square root of 6, if I want to take the derivative of 6 square root x, then I'm going to take the derivative of 6x to the 1/2 plus 8. So we're going to call that a rewrite. Okay, and the reason that we're having to rewrite it is that what rule did I teach you? The power rule. So it has to be written in a power form for you to be able to use that rule. Now you do it the same. So what do I do with the 1/2? I times it down on the, what's 1/2 times 6? 3 in the front. And then I need to take away 1. You can still do that with the 1/2. What's a 1/2 if I take away 1 from that? Negative a 1/2. Very good. And then what's going to happen to the plus 8 if it's just a constant? Goes to 0. That's right. Okay, so you did it. Okay, so one more time, let's go through it again. Power rule says I times this to the front, 1/2 times 6 is 3. Then when I take away 1, if I had a 1/2 and I take away 1 from that, then I'd be at negative a 1/2. Okay? So now let's plug in our numbers to the derivative and see if they match. Okay, LIM. X approached 9 from the left of f prime. And then LIM. X approached 9 from the right. Let's do this side first. I'm plugging into 9, so it'd be 2 times 9 minus 5. 2 times 9 is 18 minus 5 is, so my slope from the left is 13. Okay, now let's talk about plugging in the 9 here. So I'm going to have 3 times 9 to the minus a 1/2. Okay, let's review how to do that. You should have done this in algebra 2, but just in case you forgot. Okay, what is a 1/2 power the same as? You already have written this in your notes. A square root. Okay, now a negative power belongs in the bottom of a fraction. So this is the same as 9 on the bottom in a square root. Okay, the negative puts it in the denominator. And do you remember like when we had e to the minus x, how it fractioned itself? That's because of the negative in the power. Okay, then the 1/2 is still a square root, which is going to drop it into the denominator. We're going to practice this more for the next 2 A days. Okay, so for now, we're just kind of baseline touching it. You shouldn't have square roots in your homework today. You will not, but we'll practice it more.
It's 1.
It is 1 because the square root of 9 is 3. 3 divided by 3 is 1. So my left side slope is 13. My right side slope is 1. That means overall, what's my answer? Continuous, differentiable, or both? Okay, continuous, but not differentiable. Okay? All right, yes. Do you have to write it? Do you mean like up here? If you can do it in your head, that's fine. Yeah. All right. Okay, there is one other type of question that you're going to see on your homework. So are you okay with us just finishing? You know, instead of taking a break? Okay, great. All right, look at number 5. Okay, okay, last type of question. Do you remember when we did continuity that we learned how to check if it's continuous, and then we said find the constants to make it continuous? Do you remember that? Okay, we're going to do the same thing with differentiability. Okay, you learned how to check if it's differentiable. Now we're going to make it differentiable. Okay, so I'm going to give you the steps, then we're going to do it. Okay, if you want to make it differentiable, you're going to set the left equal to the right. And then you're going to set the left derivative equal to the right derivative. And then you're going to plug in the breakpoints and solve. So remember, left equal to right makes it continuous. But if it's differentiable, we know it had to be continuous in the first place. Okay, then if it's differentiable, we know the derivatives had to match. So I'll set the left and right derivatives equal. Then you'll plug in your breakpoint everywhere and solve. That's the game plan. Okay, so let's do it. Okay, with this one. Okay, first thing you're going to do is set left and rights equal. So my left is a 2x squared. 2x minus x squared equal to x squared plus kx plus p. Okay, that's setting the left and rights equal. Okay, then I'm going to set left and right derivatives equal. This is where you have to be able to do the power rule. So can you tell me, please, the derivative of the top? 2x goes to what, though? 2 minus 2x. Okay. And then for the bottom, what's the derivative of the bottom? X squared would go to 2x. Okay, and then for my kx, remember, k and p are constants. So my kx is a kx to the 1. What's 1 times k? 1k. And then my x is going to drop to the 0, which means that x is gone. Okay, what about my p by itself that was a constant alone? Goes to 0. Very good. So this is L prime equal to R prime. Okay, this is L equal to R. Okay, but this is why I said if you can't take derivatives, then we're screwed. So we got to do that first. Okay, but remember, K and P are constants. They're constants we don't know, but they're numbers. Okay, so right here, Reese, we can do it. Okay, take your breakpoint, plug it in. To both. What is my breakpoint? What number are we talking about?
1.
1. So this is 2 times 1 is 2. Minus 1 squared is 1. That'd be a 1 squared is still a 1. Plus k times 1 is a k plus p. So that's 1 equals 1 plus k plus p. Let's minus our 1 across. That means 0 equals k plus p, which means let's minus the k across that negative p and k are equal to each other. All right, now we're going to do the exact same thing in our second equation. What's x going to be? 1. So this is 2 minus 2 times 1. Okay, 2 times 1 is 2. 2 minus 2 is, so 0 equals 2 plus k. Minus the 2 across means that your k is a negative 2. Okay, your k is a negative 2. Okay, then I want you to think about that if your k is a negative 2, p is a negative k. So if it's a negative negative 2, what's p? Positive 2. Okay?
Got it?
Yep.
Bro. You just copied I did it myself.
All right. We're going to do one more where you have to do a substitution. Well, it's that, I think, is at that end of this? Yes.
Yeah. So we're
We're going to do one more. Go to number 7. Okay, 7 is the real last one. Okay, do it.
I could have moved up to slide it. Bro, always do the slider bus is just line them move along. Yeah, my slider.
All right. Y'all give it a shot. It's so easy. Let's do it. Okay. We'll be finished by 10. Okay.
Up there.
Okay, gentlemen. We're almost done. Hang in there.
Sorry.
That's okay. So you're setting the originals equal. Then you're going to set the derivatives equal. So let's try to take the derivative on your own. So no talking, but looking at each other. Do it. You haven't even written it down? Bad boy. You're fired. Do it. Okay, so if you don't know what you're doing, you're taking the derivative of this side, setting it equal to the derivative of this side in this space on your paper. What did you say? What is the A?
No, like, because it says ax squared. Is it 2x? Wait.
Yes. Very good. So if you didn't hear, when you take the derivative, remember you're timesing the 2 down to the front, which makes your A a what? 2a, and then instead of an x squared, now it's a what? Regular x. What happens to the 8? Goes away. Other side. We had a 2x squared. What's that go to? Okay, and then the derivative of the plus b, that's a bx to the 1. So what's 1 times b? 1 times b is b, and then x drops to the 0. What happens to the plus 5 if it's a constant? Goes away. What's my x? -1, and I'm plugging it into both sides. So I'm going to start with this side just because it's shorter. So it's 2a times -1, 4 times -1 plus b. So that's a -2a, -4 plus b. Okay, we're going to stop that side there. We'll come back to it. Okay, come over here, plug in your -1. Okay, we're plugging in a -1 everywhere that there was an x. Okay, remember that a -1 squared is going to cross out to a +1. So that makes my, thank you, my original a regular a plus 8. Oh, this young man is not here. Thank you so much. Okay, then on the other side, this is going to be a +2 minus b plus 5. So let's turn this into a 7. Okay, from here, what do you think you should do? Okay, you need to pick a side and solve for a letter. Okay, this is solving a system by substitution. We've already covered this, we're reviewing though. So I'm going to pick to solve this side for b. So how could I get b alone on this right side, +4? So I know that b is equal to -2a plus 4. And then I'm going to use that substitution over here where the b was. Remember, your goal is just to get rid of one of the variables so that you can solve for either a or b. So I picked this side, but you could have picked this side. It doesn't matter. Okay, where my b is, I'm going to plug in a -2a plus 4. So I have a plus 8, 7 minus -2a plus 4. And now that my equation has only a's in it, I can solve it. So a plus 8 is going to stay. 7 is now minus a -2a is a plus 2a. Minus will go to the 4. So we have a plus 8 equals 7 minus 4 is a 3 plus 2a. We need to get our a's together, so I'm going to minus this a across. So I have 8 equals 3 plus a, which means that a is what? Minus the 3 across, your a is a 5.
Oh, yeah.
Good? Okay, then once I know my a is a 5, I can go back and find my b that goes with it. So my b would be -2 times 5, which is -10, plus 4 is -6. Okay, for this section of your homework, okay, you will probably get a fraction or two. So they're not all going to be like 5 and 6 or 6 and 7. Okay? You can do it? Should we do another example or? All right. It's okay. I'll leave it up here. I'm just unlocking your homework.